Hey there, Mr. Weaver here, and this is Topic 7, Lesson 3, Multiplying Polynomials. After this lesson, you need to be able to multiply polynomials, and you need to be able to find the area of rectangles with polynomial or unknown side lengths. You'll know you're successful after this lesson if you can use the product rule of exponents, multiply using distribution or an area model, and calculate the area of a rectangle whose sides are polynomials. First, before we begin multiplying with our polynomials, let's review what the product rule is. So back in topic 6, we learned the product rule of exponents. That says that when you're multiplying two numbers with the same base, you add the exponents. So if we had x to the second power times x to the third power, that would be x to the fifth power. The base stays the same, you add the exponents. That's going to be very important in this chapter as we're going to be multiplying a lot of things with the same variable base. So now that we've reviewed the product rule, let's look at our first example. We're going to start multiplying monomials with monomials, then we'll progress into monomials and binomials, binomials and binomials, gradually increasing the number of terms that we're multiplying. Sort of like when you first learned to multiply, you started with single digit, then progressed into 2-digit and 3-digit, and so on. So first, what is the product of negative 4x to the 4 and 5x to the 2? To figure this out, we are going to multiply the coefficients and then multiply the variables and stick them back together. So if we have negative 4x to the fourth times 5x to the second, we would multiply negative 4 times 5, the coefficients, and get negative 20. We would also multiply our variables. X to the 4 times x to the 2 is x to the 6. Again, following that product rule. Now our final product is putting those back together, negative 20x to the 6. Now it's your turn. Pause the video. Figure out what is the product of 2x to the third and negative 3x to the second. Let's check. You should have found that it was negative 6x to the fifth power. 2 times negative 3 is negative 6, and x to the third times x to the second is x to the fifth. In this next example, let's start adding more terms. So what is the product of 3x to the fourth and 3x squared minus 2x plus 6? As we move forward, you are going to have at least two options of how you want to multiply these out. For this one, let's look at the distribution method. So the distribution method means that whatever's out front, you are multiplying it to every term inside. So to do this, we would just distribute. We would take that term out front, 3x to the fourth, and multiply it by each term inside. So we're going to do it one by one. 3x to the 4 times 3x to the 2 would be 9x to the 6. Then we would do the outside term with the next one. 3x to the 4 times negative 2x. We would end up with negative 6x to the 5. Remember, there's a hidden 1 on that x that's by itself, so it would be 4 plus 1 to get to the 5. Finally, we would do 3x to the 4 times 6 and get 18x to the fourth. Now, for our final polynomial product, we would put it all back together. 9x to the 6 minus 6x to the 5 plus 18x to the 4th. So one of the ways you can multiply is by distributing. Now it's your turn. Pause the video and find the product of negative 2x squared and x squared plus 4x. Distribute to find the product. Let's check. You should have got negative 2x to the 4 minus 8x to the 3. This next example involves the product of two binomials. And honestly, knowing how to do this example and others like it is probably your most important skill in this lesson, as these are the ones that tend to come up the most. So what is the product of 2x minus 5 and 2x plus 3? You're going to see it written out like this, where it's the two binomials connected. For this, you could distribute, or you might hear people say FOIL, which stands for first, outside, inside, last, and is an acronym to remember which ones to multiply. Essentially, it's just reminding you that for distributing here, you would take that first term and multiply it with both things in the second. So you would end up with 4x squared and plus 6x. But that's not all you have to distribute, because you still have that minus 5. It also has to get multiplied to everything in the second. So you would end up with minus 10x and minus 15. You'd have to put them all together, and you would end up with 4x to the second minus 4x minus 15. In the middle there, that minus 4x comes from combining the plus 6x with the minus 10x. For a 2 by 2, a binomial by a binomial, distributing is not overly complicated, but as we get to larger polynomials, like 2 by 3 or 3 by 3, the next method is probably going to be more helpful. The other way you could solve this is using an area model. So to do this, just like an area model with number multiplication that you might have learned in 3rd or 4th grade, you take how many terms and make boxes. So this had 2 terms, it's 2 boxes wide, 1 box for each term. So 2x gets a box, negative 5 gets a box. Then you are multiplying it by 2 terms, 2x plus 3. So you would make it 2 boxes tall. 1 box for 2x and 1 box for positive 3. For this method, you are just going to multiply what's on the side with what's on the top to fill each box. So 2x times 2x would be 4x to the second power. 2x times negative 5 would be negative 10x. 3 times 2x would be positive 6x. And 3 times negative 5 is negative 15. With this model, if you set it up correctly and have things in standard form, what ends up happening is your like terms, when you need to combine them together, are diagonal of each other. So I would still combine those two together and end up with the same product, 4x squared minus 4x minus 15. Now it's your turn. Pause the video. What is the product of negative 3x plus 4 and 4x minus 1? You may use either the distribution method or the area model to figure it out. They both should give you the same answer. Let's check. You should have got negative 12x squared plus 19x minus 4. Here is what the area model would look like. I have negative 3x plus 4 on top and 4x minus 1 on the side. Multiplying through, I get those values. To get that 19x in the middle, I would end up combining positive 3x and positive 16x to get my final product. Next, let's get into some real applications of this, as in finding the area of a rectangle. So here we want to find the area of a rectangle that has a length of x squared plus 2x minus 1 and a width of negative 4x squared plus 3x plus 4. So we want to know this area of a rectangle. It says that it has a length of x squared plus 2x minus 1, and it's a width of negative 4x squared plus 3x plus 4. If you notice, this is already set up as the area model. I just now drew some lines to divide it into boxes. So if I want to know the area of this rectangle, I'm going to just use this area model, start filling things in. So negative 4x squared times x squared would be negative 4x to the 4. I could keep going and filling in boxes, multiplying what's on the side with what is on the top. Now, when I'm combining like terms, I'm going to start in the top left with the one that has the highest power. So negative 4x to the 4, there's nothing to combine it with. Then I have 2x to the third powers, so combining those together would be minus 5x to the third. I have 3x to the second power terms, combined together would be positive 14x to the second. I have 2 terms that have an x, together they would make positive 5x, and just that minus 4. By starting in that top left corner and working our way down into the degree, we are already putting it in standard form as we go. So that would be our final area of our rectangle. Again, it doesn't necessarily look like it might be the answer to an area as what you are used to. However, because our side lengths were polynomials, our answer is a polynomial. Now it's your turn. Pause the video. What is the area of the rectangle with those two polynomial side lengths? Let's check. You should have got 10x to the fifth minus 11x to the third plus 8x to the second plus 3x minus 4 as your polynomial expression. Here's how to get that. If we had this area, notice how I set it up, it looks a little different. That's because we're actually missing terms within our polynomials. So on the top, we had 5x to the third. There were 0x squared terms, then minus 3x plus 4. On the side, we had 2x to the second, but 0 x's, and then minus 1. Why I did that, even though I'm filling in a bunch of areas with zeros, by doing it this way, it still lends itself to having like terms be diagonal. So I would just combine the things that are the same. Here, really only the x to the thirds need to be combined. Everything else is by itself, but this just shows that it's still diagonal of what is there. Let's look at one last example of how polynomials can be used in finding the area. So Carmelita is placing a rug in the middle of her bedroom. The length of the rug is 2 feet more than the width. What is the area of her bedroom? So first we want the area, which means we need to multiply. So multiplying is length, which we'll say is sideways across the room, including the rug and where the rug is not. And then the width going up and down, again, including where the rug is and is not. So to figure out those, let's start with the length. So on the left side, we have 5 feet without the rug. That's still part of the length of the room. Then we have W plus 2 because it's the width plus 2 more feet. That is how wide the rug is there. On the other side, we also have another 5 feet. Altogether, the length of the room would be W plus 12. I just combined like terms to simplify it down. So I'm going to write W plus 12. For the width, I'm going to do the same thing. It was 3 feet on the top without the rug, then the width of the rug, and then 3 feet on the bottom without the rug. Altogether, that would be W plus 6. Now, if I want to find the area, I'm going to multiply it out. Here I used an area model, but we could also distribute. I would end up with those multiplied terms, combine like terms. The area of her bedroom is W squared plus 18W plus 72. Again, it might not look like a traditional area answer, but since we're multiplying polynomials, our answer is a polynomial. Until we know the exact width of the rug, then we could figure out the rest. Now it's your turn. Pause the video one last time. See if you can figure out the area of the parking lot that does not need to be repaired. Let's check. You should have found the area that does not need repair is 89x to the second power. For this one, you're going to need to multiply, but also use our rules for adding and subtracting that we learned in the previous lesson. So you would take the area of the whole lot minus the area of the repair. So the whole lot is 13x times 7x. The repair is x times 2x. Multiplying those out, 91x squared minus 2x squared is 89x to the second power. In this lesson, we learned about multiplication of polynomials. So when polynomials are multiplied, it follows the rules of the distributive property and the product rules of exponents, where each term in the first polynomial is multiplied by each term in the second polynomial, and within each multiplication, the exponents are added. Here we saw two methods for multiplying polynomials. There are others. We saw the distribution method, also known as foiling, and the area model. Both methods will work to multiply any polynomials. However, the area model might work better for larger polynomials, as it kind of helps you keep track of which ones you've multiplied already and which ones you haven't. But if you like distributing better, that is up to you. After you've multiplied every term in the first by every term in the second, then you combine like terms to simplify it into one final polynomial product as your answer. Finding rectangles is one real life kind of situation that involves multiplying, since area is involved in multiplying the sides, and multiplying polynomial areas is no different, except your area will be a polynomial, which might not seem so useful, but if you're not sure of the side lengths, but you know how things compare to each other, keeping that as polynomials can help you figure out the area without actually knowing what the dimensions are. So after this lesson, do you now know how to multiply polynomials using either the distribution method or an area model? And can you find the area of a rectangle with polynomials as sides? If you're not sure about those things, go back and look at the different examples for distribution, for the area models, and how those are related to finding the area of a rectangle. And that's the end of lesson 3 on multiplying polynomials.